Okay, so the first question says, a milkman sold a milk containing 6% of water. What quantity of pure milk should be added to rupees 15 per liter of solution so that the water content comes down to 1%? So, so there are milk and water in the particular solution over there. So for that we need to see a method. What is that method? Suppose there are two. Suppose there are two types of. Let us say there are two types of uh, solutions. There are two types of solutions. Okay, one solution has got the price of one solution. Let's say the price of one solution is C, and the price of the second solution is D. Okay, price of the first solution is C, and price of the second solution is D. Mind you, the C is the cheaper one. Okay, if we compare the price of both of them, the C is the cheaper one and D is the dearer one, that is the costlier one. Okay, dearer one or the costlier one. Okay, so if these two types of solutions are to be mixed, then to find out that in what ratio they should be mixed, so that the mean price of the mixture, so that the mean price of the mixture that we are going to form, let's say if we want that mean price to be m. Okay, so C is one type of solution which has a cheaper in price. D is another type of solution which has got dearer in price or costlier in price. And if we want to mix cheaper and dearer one, then we want to make the price of the complete mixture to be m. So we want to know in what ratio we should make C and D, or what part of C should be taken and what part of D should be taken, so that the mixture mean price of the mixture is M. So if you want to know this, then there is a method of alligation. That method says, let's keep the C this way, D this way, and the M at the center. So in what ratio they should be mixed? So obviously C is the cheaper one, D is the dearer one. So we will do first D minus M. We will do D minus M and we'll just write beneath C, and then M minus C. The another side will be M minus C, and we'll write the M minus C just beneath D. So there are two values that will come out to be, that is D minus N and M minus C, and that should be the required ratio only. The ratio should be D minus M to M minus C. That means D minus M quantity of the cheaper part of the solution will be taken, and M minus C quantity of the dearer part of the mixture to be taken. If we do that in the same ratio, then the price of the complete mixture that will come out will be nothing but the M. So this is what is a method. So let we can apply this method to the particular question given to us. What is that question? Sold a milk containing 6% of water. So we can have two solutions as there is 6% of water in it. Okay, so we can compare it like 6% of water, then there has to be 100 minus 6, that is 94% of the milk over there. What quantity of pure milk should be added to it? Okay, so the pure milk will have 100% of milk. So we have got first solution as the solution which has got 6% of water. So how much will be the milk quantity? Milk quantity will be 100 minus 6%, that is 94% of the pure milk quantity in the first solution. And we have to mix this with the pure milk. Okay, how much? The second solution is nothing but the pure milk. Okay, second solution is nothing but the pure milk, and obviously the pure milk that is to be added will have 100% milk content into it. So the two solutions are there. So we can consider 94% one as our cheaper one in the method earlier given. We can consider the 94% one as the cheaper one, and we can consider the 100% one as the dearer one. If we do that, then we can reframe the same chart again. Okay, so on the cheaper side we can keep 94, on the dearer side we can keep 100, and the mean price we want to make is, as the question suggests, that in what ratio this should be mixed up so that the water content comes down to 1%. So if the water content should come down to 1%, then milk content should be how much? In the remaining part, if the water content is 1%, then milk content will be nothing but 100 minus 1%, that is 99%. So the mean that we want to make out of the two, 94 and 100, is 99. Okay, 99% milk should be there. This is what we want to make. Now we can do the same thing, D minus M. So 800 minus 99 will be 1, and M minus C, that is 99 minus 94 will be 5. So the ratio of these two mixtures should be 1:5. One should be which one? One should be that one which had got 6% water into it, and 5 parts should be which one? That is 5 times should be which one? The pure milk. So the pure milk should be 5 times the milk content in the original mixture. Okay. Now how much is the original mixture in the earlier content is 15. So the milk content that should be poured is nothing but milk content that should be poured is 5 times of 15, that is nothing but 75 liter. Okay, so the pure milk that is to be added with 15 liter should be 75 liter. Then the composition in the new mixture of the milk will be 99% and water will be just 1%. So the right answer becomes 75 liters. Option number B. Now, what says second question? The three containers of different sizes, that is 2 liters, 4 liters, and 5 liters, contains a mixture of milk and water in the ratio 1 is to 3 is one ratio, 3 is to 1 is another ratio, and 3 is to 2 is another ratio. So there are three different mixtures given, which have got three different milk and water ratio into it. Okay, so they are saying find the ratio of the milk and water when the mixture of all three containers is poured in the vessel. So there is no different compositions have been poured from different mixtures. Rather, all of the mixture of all three quantity has been mingled together, and then we want to know the milk and water ratio in the mixture. Okay, so the composition already given. The 2 liter mixture has got 1 is to 3 of milk and water. Your 4 liter has got the composition as 3 is to 1 again of milk and water, and the 5 liter one has got the composition as 3 is to 2 again the milk and water, and all these three types of mixture have been poured. So just for an example, how much will be the milk part in the first type of solution? If we want to know how much will be the milk part in the first type of solution, what we can do is the milk part in the first part of the solution will be 2 divided by milk part in the first type of solution will be 2 divided by 1 plus 3 into 1, that is nothing but 2 into 1 by 4. So this is how we can find out the parts of each and every value. So the water part in the first solution will be, that will be 2 divided by sum of ratio terms into the water part value, that is 3, which is nothing but 2 into 3 by 4. So in this way we can find out each milk and water component in different mixtures, and we want to know the total ratio of the total quantity of milk to total quantity of water. That we can find out by total quantity of milk divided by total quantity of water can be found out by adding each milk and water content to each other. Okay, so let us add the milk content. Milk content in the first part we have already calculated is 2 into 1 by 4. We can again write down here 2 into 1 by 4 is the milk content in the first solution, plus milk content in the second solution. Milk content in the second solution will be the total solution is 4 divided by sum of ratio term, that is 3 plus 1, multiplied by the milk part of it. The milk part of it is nothing but 3, so multiplied by 3, plus milk content in the third type of solution, that is total solution is 5 divided by sum of ratio terms, that is 3 plus 2 into milk part in the third content is 5, so multiplied by 5. So this will be the numerator will be total quantity of milk in the mixed solution. Let us find out the total quantity of water. So water content in the first part we already calculated that 2 into 3 by 4. So we can just copy that from there, plus water content in the second solution. Second solution has got 4 as the total quantity. Sum of ratio terms is 3 plus 1 multiplied by water part is 1, so into 1, plus 5 is the total solution. The third one, sum of the ratio term is 3 plus 2, and the water part this time around is 2. Milk part in the earlier one was 3, not 5. Water part in the second one is 2. So this is the complete expression that comes out in front of us. Now we can find out the solution of this. If we solve this further, this comes out to be 1 by 2 plus 3 divided by 3 by 2 plus 1 plus 2. If we add them together, this comes out to be 7 by 9. So that's what going to be the milk and water ratio in the new mixture that we create. Is answer is 7 is to 9, which is available in option number D is the right answer. Now next, rupees 675 was divided among 75 boys and girls. Each boy gets rupees 20, whereas a girl gets rupees 5. Find the number of boys and girls. Okay, so we again have got the same method of cheaper to dearer. We have got this method as covered in question number 1 also. Cheaper, dearer. Okay, the ratio in which they should meet is D minus M and m minus c. This should be the ratio. So we can again make use of this allocation method. How we can do that? See, rupees 675 was divided amongst 75 boys and girls. So the average money given per head, average money per head, okay, either to a boy or to a girl, average money per head was, total money was 675 divided by total number of boys and girls together was 75. So the average money that was given to each and every boy and girl is rupees 9. So that average can be treated as the mean price of the two values. What are the two values? They say boy gets 20, so that can be treated as the dearer part, and girl gets rupees 5, so that can be treated as the cheaper part. Okay, so we can again make that allocation chart. Cheaper part is 5, dearer part is 20. The mean price that we want to make is the average one, and then we can find out the ratio in the same format as done above. So 20 minus 9 is going to be 11, and 9 minus 5 is going to be 4. Okay, 5 was the girls part and 20 was the boys part. So the ratio in which they should be given the money is boys to girls should be 11 is to 4 is to 11, rather 4 is to 11. That should be the ratio. Okay, now we have to distribute this 4 is to 11 with each boy and girl. As they say, how many number of boys are there? Let us find out the number of boys now. So number of boys can be found out by, see, the total fraction is 4. Total fraction is total strength is 75. Now this 75 is to be distributed between 4 is to 11. So the number of boys will be 75 divided by sum of ratio terms multiplied by the boys part. Boys part is nothing but 4. So multiplied by 4, which gives us the value as 20. And similarly, number of girls can be found out by total strength is 75 divided by sum of ratio term is again 4 plus 11 multiplied by the girl part is how much? Girl part is 11. So if we solve this comes out to be 55. So number of boys is 20 and number of girls is 55. That's what is the answer, and that is available in option number A. 20 is 20 and 55. Next, a mixture of certain quantity of milk with 16 liter of water is worth rupees 90 paise per liter. If pure milk costs 108 paise per liter, then the amount of milk in the mixture is. Okay, this is what is the question given to us. So what all we can do, again we can make use of that particular formula where there one side is dearer, another side is cheaper, and the mean price is m, and then in what ratio they should be mixed up? They should be mixed up in the ratio m minus c and d minus m. We can again make use of this fact. How can we do that? See, they say the pure milk cost 108 paisa per liter, so that can be treated as the dearer one, the costlier one. And cheaper part, what is mixed in it? They say mixture of certain quantity milk 60 liter of water is worth to be 90 ml. If pure milk costs 100, then the amount of milk in the mixture is. So the cheaper part is nothing but the water. Okay, the cheaper part is nothing but the water which is free of cost. Okay, the water which is free of cost, that can be treated as the cheaper part in the chart. The mean price they want is a mixture of certain quantity of milk with 16 liter of water is worth rupees 90 paise per liter. So mixing the milk and the water together, the mean price has been made as 90 paise per liter. So the mean price can be treated as 90 paise. Okay, now let us find out that. Let us keep down our values. The value given to us are, the first value is the dearer part, that is the milk part. Okay, first value is the dearer part, that is the milk part, that is 108 is the rate. That has been mixed with water with zero price, and the mean price of the mixture has become 90 paise per liter, as they say it already. Now in what ratio they should be mixed up? So obviously 90 minus 0 is going to be 90, and 108 minus 90 is going to be 18. So the what is this ratio coming? 5 is to 1. That means the milk part has to be 5 and the water part has to be 1. Okay, so we can say that milk is to water ratio is 5 is to 1. But as they already say that the milk with 16 liters of water, so water quantity is already given out to be 16, so we need to know the milk quantity. Okay, so the water part is 16 part, so milk quantity should be how much? So as you can see, the milk part is nothing but 5 times of the water part. So the milk part in this case should be 5 times of 16, that is nothing but 80 liters is the quantity of milk in the solution given to us. Answer becomes option number B, 80 liters. Now, In the next, they say, in what ratio must a grocer mix two varieties of tea worth rupees 60 a kg and 65 a kg, so that by selling the mixture at rupees 68.20 a kg, he must gain 10%. So what all is given to us? Cheaper price is given to us at 60 rupees. Okay, cheaper type of uh, tea is of 60 rupees per kg. Dearer type of tea is nothing but 65 rupees per kg. He says that he mixes them both and then he sells them at a price, and at that, if he sells that at, he sells that, he makes a mean price first, and then he sells it at a different price, that is 68.20, gaining thereby a 10% profit. So whatever would have been the mean price, that would have been treated as a cost price for him, and he would have gained 10% in it, and then he has sold it at 68.20 rupees. So 68.20 is the selling price. The mean price is nothing but the cost price itself. So we need to first of all find out the cost price if the selling price is 68.20 and profit is 10%. So we have got a simple formula for cost price. When the profit happens, the simple formula for cost price is nothing but 100 over 100 plus profit percent multiplied by the selling price. So we can find out the cost price, or that will be treated as the mean price of the solution, that can be found out by 100 divided by profit is 10%. So it has to be 110 into 68.20. Okay, if we solve this further, this comes out to be rupees 62. So the mean price that the mixture can be made to is rupees 62. Now we can make use of our own chart. The cheaper part can be written any side and the dearer on the other side. Mean price that is to be made is 62. In what ratio they should be mixed up? So obviously dearer minus cheaper gives you 3, mean minus cheaper gives you 2. So the ratio that should be there is 3 is to 2. That means three part should be of the tea that is 60 rupees per kg, and 2 part should be of the tea that is 65 rupees per kg. So the ratio of the cheaper tea to the dearer tea is comes out to be 3 is to 2, and that should be the right answer, which is available in option number D. Now, in what proportion is water mixed with juice to gain 10% by selling it at a cost price? Okay, they say in what proportion is water mixed. So water is obviously free, so water should be mixed with juice to gain 10% by selling it at a cost price. So as they say, selling price is equal to cost price. So if the selling price is equal to cost price, so whatever water you have added, okay, water that has been added, okay, the price of that water is nothing but you are selling at the price of the juice. Okay, because water, you have mixed the water that was free to you, and whatever quantity of water you have mixed inside it, that particular quantity you are selling at the cost of juice. So that means whatever that quantity is there, that should be your profit percent only. Okay, what do we mean by that? See, profit percent, as they already say, is 10%. 10% can be written as 10 by 100, which is nothing but 1 by 10. So 1 by 10 is the profit. Whatever is the investment, 1/10 of that is the profit. So that 1/10 is nothing but you have added as water only, because you are selling the things at cost price only. So you have added 1 by 10 of water into it, and you are selling the 1 by 10th water in the price of juice itself. So that's what it becomes your profit only. The 1 by 10 of the cost price, that becomes your profit. So they ask in what proportion is water mixed. So if you are gaining 1 by 10 profit, then obviously the proportion that would have been mixed is, if you say water to juice, will be nothing but 1 is to 10 only. Okay, 1 part of water in 10 part of juice, and that's what becomes your profit also, giving it a 10%. So the ratio of water is to juice. The ratio of water is to juice is nothing but 1 is to 10, available in option number C, and that is the right answer. Now, seventh, what they say, how much black grams worth rupees 70 per kg is added to 15 kg of wheat worth rupees 40 per kg, so that the price of the mixture is worth rupees 52 per kg. So what they say, so there are two types of black grams only, two types of variety. One variety is the dearer one, that is the costlier one, 70 rupees per kg. Another one is the cheaper one of 40 rupees per kg. So we can again make use of our chart, dearer one, cheaper one, mean price, and then the ratio can be made as d minus m on this side and m minus c on the other side. So what, in what ratio they should be mixed? M minus C is to D minus M. That should be the ratio of mixing them together. Now, so the dearer part is 70. So let us write 70. Cheaper part is 40. Mean price they want it to be 52. So that should be the mean price. Let us solve it. 72 minus 52 will be 72. It's going to be 72 type of 72 70 per kg. It's not 70. It's not 70. It's 70, 72. It's 70. So 70 minus 52, that's we are supposed to do, is going to be 18, and then 52 minus 14 is nothing but 12. So 12 is to 18 should be the mixture, which is nothing but 2 is to 3. So the 70 rupees per kg should be 2 part, and 40 rupees per kg one should be 3 part. Okay, but the part of the 40 rupees per kg is already given. Okay, that is 15 kg. So they are asking, if this 3 part is 15 kg, what is the 2 part? Okay, if this 3 part is 15 kg, what is the 2 part? So we can write like 2 is to 3 is what is to 15. So we can use that ratio and proportion concept. The product of outer terms is product of inner terms. So it's going to be 15 into 2 is equal to 3x, which gives us x value as 10 kg. So how much should we mix? We should mix 10 kg of it into it. And if we mix 10 kg into it, then the particular mixture will have the mean price as rupees 52 per kg. Answer is 10 kg B. Okay. Next one, in what ratio must a sweet worth rupees 850 per kg is mixed with a sweet worth rupees 1180 per kg, so that the mixture is worth rupees 960 per kg? So we know that method: cheaper part, dearer part, and the mean part. In what ratio they should be mixed up? They should be mixed up in the ratio of their differences. That is D minus M is to M minus C. In this particular ratio they should be mixed up. So which is our cheaper part? Cheaper part is the part which has got 850 rupees the price. Dearer part is the costlier part, which has got 1180 rupees per kg is the price. Mean price you want it to be 960 rupees. So now you can find out that D minus N M minus C. If you subtract 1180 minus 960, it gives you 220, and the other side it gives you 110. So the ratio becomes 2 is to 1. Okay, two part is the 851 and one part is the 11801. So that should be the final answer. Two is to 1. But they have, in which order they have asked? In what ratio must 850 per kg be mixed with 118 per kilo, 1180 rupees per kg? That means they are asking for the cheaper to dearer ratio. Okay, they're asking for cheaper to dearer ratio. And if we can see that the cheaper part is 2 and the dearer part is 1, so the ratio is 2 is to 1. And this 2 is to 1 is not available in any of the answers, so we can mark the right answer as E, that is none of these. 2 is to 1. Okay, now, in a mixture of rupees 50 liter, the ratio of boric acid to water is 3 is to 2. How much more water is to be added so that the ratio becomes 1 is to 4? That is the question given to us. Okay, so let us distribute that particular 50 liters, and there are 50 liters of it given. Let us first try to distribute this. Okay, 50 liters is there, and 50 liters to be distributed between 3 is to 2 first. Okay, now, so if there is 50 liters of pure solution and it has been distributed in the order 3 is to 2, where 3 should be the acid part and 2 should be the water part. So how much is the acid content? Acid content is going to be simply 50 divided by sum of ratio terms, that is 3 plus 2, into the acidic part of it, that is 3. So into 3, so this is coming out to be 30 liter. So if 30 liter is the acid, the water part should be how much? 50 minus 30, that is 20 liter. So we know that in that particular 50 liter, 30 liter is the acid and 20 liter is the water part. Now they have asked how much more water is to be added. So let us assume something. Let's say let x liter of water is to be added. X liter of water to be added, so that the ratio has to become 1 is to 4. Okay, between acid and water. So, okay, so the x liter of water has been added to give you ratio as 1 is to 4. So the acidic part remains as it is because there is no acid added. So we will take the numerator part as 30. We are doing acid over water in the new mixture. So the acidic part remains as it is, 30 liter, divided by water has been, earlier the water was 20, and how much we have added? We have added x. And they say that if you do this exercise, then your ratio should become, acid to water should become 1 is to 4. So now we can cross multiply this. If we cross multiply, we're going to get 120 is equal to 20 plus x, giving us x as 100 liters. So giving x as 100 liter. So how much water should have been added to make it the ratio acid to water 1 by 4 is nothing but 100 liter, which is available in option number B, and that is the right answer. Now, a trader has 1330 kg of sugar, part of which he sells at 11% profit and the rest at a loss of 3%. He gains 7% on the whole. What is the quantity sold at 11% profit? So we can again do this method by method of alligation or mixture. See what we do in our alligation or mixture method. There is cheaper part, there is dearer part. Then we want to know in what ratio they should be mixed up so that the mean price becomes M. So that's what we can do here also. But by how we can do that? There is a profit 11%. So this 11% can be treated as dearer part. And there is a loss of 3%. So this loss can be treated as minus 3, because there is a loss, so negative sign is involved, minus 3% and treated as cheaper part. Okay. Then gain, the overall gain has happened as 7%. So the mean should be treated as 7%, as it is a gain. So the sign is plus. Okay. So this is how we can associate our variables D, C and M, and we can put that into the chart. So if we do that, the cheaper part is minus 3, that is 3% loss. Dearer part is 11% profit, so it is a plus. Mean is ultimately he has gained 7%, so 7% in the on the plus side is the mean price. Now in what ratio they should mix up this? Okay, we can find out. 11 minus 7 is going to be 4, and 7 minus minus 3, that is 7 plus 3 will be 10. So the ratio in which the loss quantity in which the loss has happened and the profit quantity in which the profit has happened should be 4 is to 10 or 2 is to 5. Okay. So 2 part should be the loss one and the 5 part should be the profit one. Now he wants us to find out what is the quantity sold at 11% profit. That is profit. We have to tell the quantity of the profit one. Okay. So that can be found out by part sold for. We can write for part sold of 11% profit. 11% profit once part is how much? We can find out by, see, the total quantity is 1330 kg divided by the ratio of loss and the sum of the ratio parts of the loss and profit is 2 plus 5 into, we want to know the profit quantity. Profit quantity was 11% one, and the number corresponding to that 11% one was 5. So we'll multiply this ratio into 5. If we do this, we're going to get 1330 divided by 7 into 5, which comes out to be 950 kg. So how much quantity of the profit one was mixed to give you the ratio as 2 is to 5 was nothing but 950 kg, and that is available in option number B and is the right answer. Now, a 10-liter cylinder contains a mixture of water and sugar. The volume of sugar being 15% of the total volume. A few liters of mixture is released with an equal amount of water added. So what all is happening? There is a 10-liter cylinder which is containing some mixture of water and sugar. Two part have been there, in which the sugar quantity is 15 liter, or the 15% rather, not 15 liter but 15% of the total volume, that is 15% of 10. Then they say few liter of the mixture, how much has been removed, that they don't tell, but they tell that how much, some part has been removed and an equal amount of water is added. Whatever was removed, the equal water has been added back. Then the same amount of mixture as before is released and is replaced with water or second time. So the same process has been repeated second time also. So ultimately the process has been done twice. Okay. As a result, the sugar content becomes 10%. So after two such steps, the sugar content has finally become just the 10%, which was initially 15%. Okay. What is the approximate quantity of mixture released each time? So that's what they want to know. So here we can bring a formula in the scene. For example, there is X liter of pure something. X liter of something pure is available to me. And if Y liter is Y liter uh, is replaced by Y liter of some other thing. Okay, some other quantity, some other solution rather. Okay, X liter of something pure was there, in Y liter from this pure has been removed and replaced by Y liter of something different solution. And if this particular process is repeated n times, not repeated, if this particular process is performed, this replacement and adding back, replacement and adding back has been done a total of n times, then we can find out that after n such steps, how much of the pure x quantity would have remained. The pure x quantity that would have remained inside that solution would be x into 1 minus y over x to the power n. Okay, where x was the pure quantity in the very beginning, y is that particular volume that has been taken out and replaced by some other solution in multiple steps. How many steps taken? N such steps. So after n such step, how much would have been the x pure content left out in the solution? That is the formula for this particular formula relates that situation. So we can have the similar, we are having the similar situation in which the amount of sugar in the cylinder is 1.5 liter. How we can find out? They say 15 liter of sugar is there. The sugar content is 15% of the total volume. Total volume is 10 liter. So the sugar content is how much? Sugar content is nothing but 10% of the total volume, that is 10 liter itself, which is nothing but 1.5 of liter. So 1.5 liter is sugar is available, that is a pure one. Now, what they say, amount of sugar left after a liter has been removed twice is, so how much sugar would have left out? Sugar left out, okay? Sugar left out after how many times they have done it? They have done it twice. So after the sugar left out after two attempts, okay, after two such attempts would have been, we can frame the formula. So the original sugar content was 1.5, so x becomes 1.5 multiplied by 1 minus, let us assume one more thing, let a liter has been removed and replaced. A liter is removed and replaced. Let us assume this fact that a liter has been removed and also replaced at the same time. If this has done, so it has to be 1 minus a by total content was 10. Okay, and this process has been done twice, so square. Okay, so this is how the formula is brought in the scene. If we solve this, and they also say that after two such steps, the sugar content becomes 10% of the total volume. So 10% of total volume, that is 10, is nothing but 1. So this, the ultimate sugar that would have been left is just 1. So we have to solve for A. So the formula becomes 1 is equal to 1.5, 1 minus A by 10's whole square. Okay, if we solve this further, we can bring down 1.5 on the other side. So this is 0.66 is equal to 1 minus A by 10's whole square. We can write it like this, which can be further done as 0.8 is equal to 1 minus a by 10. And if we solve this further, a by 10 value comes out to be 0.2. Okay, now so the a comes out to be 2 liters. So a comes out to be 2 liters. So how much had been replaced every time is nothing but 2 liters. So that's what is the answer of the question. Option number B, not option number B, option number D, that is 2 liters is the final answer. Now, let us say the next one. Two casks of 48 liters and 42 liters are filled with mixture of milk and water. The proportion in the two casks being respectively 13 is to 7 and 18 is to 17. Okay, if the contents of the two casks are mixed and 20 liter of water are added to the whole, what will be the proportion of milk and water in the resulting mixture? Okay, so there are two types of different solutions given. One is 48 liter in quantity, another one is 42 liter in the volume rather, and they have different milk and water components. First one has got milk water ratio as 13 is to 7, another one has got milk and water ratio as 18 is to 7. So let us find out quickly. Okay, the two mixtures have got different milk and water ratio. So let us first find out first cask quantity of milk and water. Okay, so the 48 liter one has got the composition as 13 is to 7, and we are dealing in the order of milk is to water. And this 42 liter one has got the milk and water composition as 18 is to 17. Okay, that is milk is to water. Okay, that is the composition. Now we want to know the what is the total quantity of milk and water. So milk and water is nothing but, see, total quantity of milk in the first cask, the quantity of milk and water is going to be, so the first cask has got 48 liter, so the milk quantity will be nothing but 13 part and the water is 7 part. So 48, okay, 48 liter one proportional cask being 13 to 7. If the control tools are mixed, 20 liter of water are added. Okay, so the quantity of milk, okay, quantity of milk will be how much? Nothing but 48 divided by 13 plus 7. Okay, 48 divided by 13 plus 7, that is going to be 20 for us, so it is going to be 48 by 20. Okay, so that's what will be treated as the factor which can be multiplied to all the things. Okay, so the quantity of milk in the first part is, in the first case, quantity of milk is nothing but 48 divided by 20. That is, 20 is nothing but the sum of ratio terms into milk part is how much? Milk part is 13 parts, so into 13. Okay, if we solve this further, this comes out to be 31.2 liters. Similarly, first part has got how much water? Okay, we can simply subtract this. Okay, rather than solving it again, we can simply subtract it from 48. So water part will be 48 minus the milk part, that is 31.2, will be giving you 16.2. So that is the water part in the first quantity. Now let us find out the second quantity. Second solution has got how much milk part? The second composition is 42. Total volume is 42 divided by sum of ratio terms, that is 18 plus 17 multiplied by the milk part, and it is 18. So if we solve this further, this comes out to be 21.6 liter. So that is the milk part in the second solution. How much will be the water part in the second solution? We can simply subtract from 42 minus 21.6, which will nothing but 20.4 liters. So the milk and water part of both the solutions have come. Okay, 31.2, 16.2, 21.6, and 20.4 liters. Okay, now they say, what they say in the next line of the question, if the contents of the two casks are mixed and 20 liters of water are added, what will be the proportion of milk and water? So milk part to the water part, that we are supposed to know. So the ultimate milk part will be the milk part of both the solution, that is the milk part of the first solution about 31.2 plus another one has got 21.6 divided by water part, the original water part, plus 20 liter more, because that has also been added. So how much is the water part individually? Earlier, first has got 16.2, second one has got how much water part? Was 20.4. This is 20.4, and 20 is also added, further added. So if you solve this further, this comes out to be 52.8 divided by 57.2. That approximately becomes 12 by 13. So that is the new ratio of the milk part to the water part after the water 20 liter of water has been added. So right answer becomes C, 12 is to 13. Now, in the next one, they say a vessel contains a mixture of acid and water in which acid is 36%. 4 liters of mixture is taken out and the vessel is replaced by same quantity of water if the present percentage of acid is 30%. So we can again relate the same formula which says that if x was the pure quantity in a solution and y has been replaced every time, and how many steps have been taken? Total n steps have been taken. Then pure left out. Okay, the formula that we made in the last question also, the pure left out will be nothing but x into 1 minus y over x to the power n. So we can relate it like that. So let us see the question first. They say, and let us assume something. Let us say original quantity of the mixture. Okay, let us say the original mixture is how much? Let's say y liters. Originally it was y liter. Then let us assume replaced one. Okay, how much has been replaced in every step? Let us say x liter has been replaced in every step. Now, if we use this particular formula once again, how much would have been left out if we use this formula? Then we can write this as, okay, how much has been left out? They already say if the present percentage of acid becomes 30%, that after the procedure has been done, the percentage of the acid remains 30%. So replaced is 30% divided by original was how much? They say 36% was there. So let us take it as 36 multiplied by 1 minus how much has been replaced. We have assumed the replaced part is x, so we'll take it like x divided by original part is, if 36% has been taken, so original part we should take as 100, because 100 is the whole percent of the 36%. Okay, and this is, it comes out to be, if we solve for x, x comes out to be simply 50 by 3. So the value of x comes out to be 50 by 3. Now let us find out. Okay, now original quantity would have been how much? If we want to know original quantity, that will be, see, 50 by 3 has been the replaced quantity. So original quantity would have been now y minus 50 by 3. Okay, that would have been the original quantity, because 50 by 3 is the duplicate quantity or the replaced quantity. Y minus 50 by 3 divided by y only, because we want to know the percentage of it. and into 100%. What we are doing is we are trying to find out what is the percentage of pure quantity in the original quantity. So that's why we have taken the replaced one, that is y minus 50 by 3. That much is left out only, divided by the total quantity was initially y, so denominator is y, into 100%, and they already give this value as 30%. So if we solve this equation, we're going to lead to 30y minus 500 is equal to 9y, which gives us y value as 500 by 21, which is approximately equal to 24 liters. Okay, so 24 liter was that particular volume which has been replaced by water. So that option, right answer, is available in option number B, and that is the right answer. Okay, let us have the next one. 14. If 15% of a solution that has lime and water in the ratio 7:3 is removed and replaced by 50% of the water, then what is the concentration of lime in the new solution? Okay, so there is a solution of lime and water. The ratio is given as 7:3. That is the ratio given to us. They say 50% of this solution has been replaced, okay, removed and replaced by 50% of water. So let us do it one by one. Okay, so let us assume something. Let's say the total solution is 100 liters. Let us say the total solution is 100 liters. Okay, let us begin like that. So how much the total solution of 100 liter has been in the ratio of lime is to water as 7:3. So the lime part would have been how much? Lime part would have been 70 liter out of 100, and water part would have been how much? Simply 30 liters. So these are the two, lime and water part, now with us. Now they say what? 50% of a solution has been removed and replaced. So 50% has been eliminated. So that means 50 liter has been eliminated. So in that 50 liter also, whatever has been the eliminated part, in that 50 liter also, the ratio of lime is to water would have been 7:3 only. Okay, so in if in 100 liter the 7 part was 70, so in 50 liter 7 part would have been 35, just half of it. Similarly, if in 100 liter the water parts were 30 liters, so in 100, then 50 liter the water part would have been half of 50, that is nothing but your 15 liter. So 35 liter of milk, 35 liter of lime, and 50 liter of water has been removed. Okay, when 50% of solution was removed. So how much lime part would have been left out? Lime part that would have been left out is 70 minus 35, that is nothing but 35 liter would have been left out as the lime part. And how much would have been the water part left out? Original water part was 30 and 15 has been removed, so that is 30 minus 15. So 15 liter of water part would have been left out over there. Okay, now they say is removed and replaced by 50% of water. That means whatever was the total solution, that's 50%. That means 50 liter of water has been added up. So the original lime part remains as it is, that is 35 liter, because there is no addition or subtraction into it. But water part, which had come down to 15 liter because of the replacement, because the removal, has been added by 50 liter more water. So the original water part now becomes how much? 65 liter of the water is there, and 35 liter of the lime is only there. Now they're asking what is the concentration of the lime. So concentration of lime can be found out by the lime content divided by the total solution multiplied by 100%. Okay, so how much is the new lime content? New lime content is just 35, divided by how much the total content? Total is 35 plus 65 and multiplied by 100%, which gives you 35 divided by 100 into 100, that is nothing but 35%. So the new concentration of the lime in the solution is nothing but 35%, and that is the right answer, which is available in option number A. Okay, so the question says if 4 kg of an alloy made of 1 by 4th of iron and rest tin is mixed with 6 kg of another alloy made of 2 by 3rd iron and rest tin, find the ratio of iron to tin in the resultant mixture. Okay, so the first alloy is in the quantity is 4 kg, is the first type of alloy. Okay, and in that 4 kg of alloy, the composition of iron to tin is 1 by 4 is the iron part, so obviously 3 by 4 will be the tin part. Okay, if 1 by 4 is the iron part, so obviously 3 by 4. How come this 3 by 4 is made? 1 minus 1 by 4, that is 3 by 4 will be the tin part. Similarly, if we take the another type of alloy that is in 6 kg quantity, so in that 6 kg alloy quantity, what is the composition of iron and tin is? He says the 2/3 part is iron. So 2/3 of the part is iron. And how much part will be the tin then? That will be 1 minus 2 by 3. That is nothing but 1 by 3. How this 1 by 3 is made? 1 minus 2 by 3. Okay, so 2 by 3 part is your iron, and 1 by 3 part is the tin part. So what all are they? So let us find out the 1 by 4 of 4 kg. 1 by 4 of 4 kg is nothing but 1 kg. So that means 1 kg is iron. And what about 3 by 4 of 4 kg? So 3 by 4 of 4 kg is nothing but 3 kg. So 3 kg is the tin part in the first type of alloy. Now let us find out for the another type of alloy. 6 kg and 2/3 part is iron. So 6 into 2 by 3, that is nothing but 4 kg is the iron. And what about the rest part? So 1 by 3 part times the 6 kg. 1 by 3 times 6 kg is nothing but 2 kg is the tin part. So these are the iron part. This is the iron part. This is the iron part, and this is the tin part of the both type of alloy. They are saying they are been mixed up. So if we mix them, and we are supposed to give the ratio of iron to tin. So let us do the iron from the A alloy and iron from the B alloy. And let us divide this by tin from the A alloy plus tin from the B alloy. If we do this, we are supposed to add 4 plus 1. Okay, so it becomes 4 plus the 1 plus 4, it is 1. This one is 1, this one is 4. 1 plus 4 divided by another one is 3 plus 2. So it is nothing but 5 by 5. So the ratio is simply 1 is to 1. So the ratio of iron to tin in the mixed alloy in the mixture is nothing but 1 is to 1, which is available in option number A. Now let us see the next question. 16. A vessel is filled with liquid, 3 parts of which are water and 5 parts are syrup. Okay, so vessel has got a liquid whose 3 part, that is the parts and the ratio of the water and to syrup is 3 is to 5. 3 parts of which are water. So the ratio of water to syrup is nothing but 3 is to 5. How much of the mixture must be drawn out and replaced with water so that the mixture may be half the water and half the syrup? So in the new mixture, in the new liquid syrup, what should be the composition of water to syrup? He say half water and half syrup. That means the composition should be 1 is to 1. They should be equal. So for that thing, what we are supposed to do, how much of the mixture must be drawn out and replaced with water? So we need to draw out something from this mixture, and that we have to again replace it with a similar quantity of water so that the ratio becomes 1 is to 1. So that we are supposed to find out how much is to be taken out. So let us find out what is the water part in the first type of liquid is 3 out of 5. Okay, 3 is to 5 is the water is to syrup. So the water part becomes 3 divided by 3 plus 5. That is nothing but 3 by 8. So 3 by 8 is the water content in the initial mixture. Now similarly, water content in the liquid added. So they are saying it has to the how much to be drawn out and replaced with water. So the whatever is to be added into this mixture is nothing but the water only. Okay, pure water is being added. Water is being added into it. So how much part of water will be available in the water? That will be 1 out of 1. That is 100% of water. So the part that has to be added has got water part is 1 part only. So there is 1 part of water to be added to 3 by 8 part of the water in the original quantity. And the final mixture should get how much water? This is the final mixture. So water is to syrup is 1 is to 1 is to 1. So the water part should be 1 divided by 1 plus 1. That is nothing but 1 by 2. So in the final mixture, the water part should be 1 by 2. Let us revise this once again. What we are doing in the original mixture, water part was 3 by 8. In the water that we are mixing, in that the water part is 1 only. Okay, and what should be the resultant ratio of the mixture of the water is 1 by 2. So these are the 3 values that we have to take care of. And obviously we can use the alligation method that we are using in every of the questions earlier also. Alligation method, which tells us what? Which tells us that there is a cheaper quantity, dearer quantity, and there is a mean price that can be made if in a certain ratio of a mixture, and the ratio in which the two liquid should be mixed to give you the ratio of to give the mean price as M is D minus M is to M minus C. So we're going to use the formula and use the method for the same situation. What do we have got? The cheaper quantity is the 3 by 8 of water type. The higher price is nothing but in which the water quantity is completely 1. Mind you, the one is greater than 3 by 8, so that's why it's kept on the dearer side. The mean price or the mean ratio that we want to make it is 1 by 2. Okay, the mean ratio that we want to make it is 1 by 2. Now what we are supposed to do, 1 minus 1 by 2 is going to be 1 by 2 on this side, and 1 by 2 3 by 8 minus 1 by 2, or 1 by 2 minus 3 by 8 is going to give us simply 1 by 8. So these two values have come. Okay, this 1 by 2 has come by subtracting 1 minus 1 by 2, like that, and this 1 by 8 has come by subtracting 1 by 2 minus 3 by 8. Okay, that is 1 by 8. So this should be the ratio. Okay, and this ratio is nothing but 1 by 2 is to 1 by 8 is nothing but 4 is to 1. So this should be the ultimate ratio of the water that is to be mixed in the original mixture that we have. So as it suggests, 5 parts, there are total 5 parts, 4 plus 1, there are total 5 parts available. Okay, so there are 5 parts total available. Okay, 5 parts total available, in which 1 part should be replaced. That's what 4 is to 1 means, that 1 part should be replaced with water, 1 part should be completely replaced with water. Okay, it should be replaced with water. Okay, that's what is 4 is to 1 means. Out of the 5 part, 1 part belongs to the water. So 1 part should be replaced by the water of the original liquid. So that means, what is the fraction? How much is the part to be replaced? Is 1 out of 5 part is to be replaced. And that's what is the ratio also, or in the fraction part also. So 1 by 5 of the mixture should be replaced with water to give you the 1 by 2 as the ratio. So that is the right answer, option number C. Okay, let's see the next one. Rehan's expenditure and savings are in the ratio 2 is to 3. His expenditure is increased by 9%. If his income is increased by 6%, by how much percent does his saving increase if the ratio of expenditure and saving remains same? Okay, this is what is the question given. So now we can see the expenditure has got increased in the expenditure is nothing but expenditure is increased by 9%. Okay, what is the increment in the savings? Increment in the saving, if we find out, that is supposed to be found out. Okay, that is an unknown thing. That's what they ask. By how much percent does this saving increase? So let us take it as X percent. Let us say there has to be X percent increase in the saving. Okay, and then we are supposed to find out the third thing. How much is the increase in the income? Okay, how much is the increase in the income of Rehan? That is nothing but given as, how much is the increase in the income is given as his income increased by 6%. So that is the increase in the 6% value. Okay, so this is the final thing given, and they say if the ratio of the expenditure and saving remain same. Okay, what should be increment in the saving he should do, so that whatever is the original ratio, that is 2 is to 3 between expenditure and saving, the original ratio has been given between expenditure and saving as 2 is to 3. So he's saying, if the expenditure has been increased by 9% and income has been increased by 6%, what should be the increase in the saving to be done so that the ratio of expenditure and saving remains same? So we have assumed that there should be X% increment in the saving to maintain the same ratio. Okay, so we can do it this by alligation method once again. How we can do that? Okay, we can have one side the expenditure value, on the other side we can have the saving value, and the mean price should be the income. Okay, because that is that is the related part. Income is the related part. Okay, so and that in that situation, whatever is the value coming, he says the ratio of expenditure to saving should remain 2 is to 3. So we already know the ratio part. We already know the increment in the saving income part, that is 6%. We already know the income in the increase in the expenditure part, that is 9%, and we have assumed the saving part as X% increase. So this is how we can utilize alligation method to find out the same situation. Okay, now if we solve this out, then what do we get? So what do we do? Income 6 and 9, expenditure is 9, so 9 minus 6 is 3% here. Okay, and X minus 6, okay, rather 6 minus X or X minus 6, that remains same. So that should come as here. So now what should be the ratio as the chart suggests? So it has to be 9 minus 6, that is 3 only, divided by 6 minus 2. Okay, divided by 6 minus 2, okay, should be equal to 3 by x. That's what it becomes. So there where the x value comes out to be exactly 4%. Okay, x value comes out to be exactly 4%. So this is an easy method of solving out the three values over there, and they are easily relatable by the allocation method. So the increase in the saving should be 4% to give you the ratio again as 2:3. Answer is 4%, which is available in option number A. Now, let's say the next one. In the ratio in which an article costing rupees 72 per unit is mixed with an article costing rupees 42 per unit, so that the ratio of the mixture costing rupees 60 is. Okay, so we are supposed to find out. It is the same situation that we utilized using the allegation method. There is cheaper quantity, there is dearer quantity, there is mean price, and what should be the ratio to have given you the mean price of the two quantities should be D minus M is to M minus C. That should be the ratio given. Okay, this is how the four variables are related. The D minus M is to M minus C should be the ratio to maintain the mean price of the two types of quantities being mixed up. Okay, so where is the cheaper quantity? The cheaper quantity is the is the is the price of rupees 42. Dearer quantity is the costlier one, is the price of rupees 72, and they are supposed to be mixed up in a certain ratio so that the mixture should be costing 60 rupees. Okay, what should be that ratio? So we do 72 minus 60 and keep right down here. That is nothing but 12. Then we do 60 minus 42 and write down here. That is nothing but 18. Okay, so and this should be the ratio 12 is to 18, which is nothing but 2 is to 3. So 2 is to 3, this should be the ratio in which if the 42 rupees per kg unit is mixed with 3 part of 72 rupees per kg, and then the resultant will have, the mixture will have the price as 60 rupees per kg. So the right answer becomes option number C, which is 2 is to 3. Next, what says the 19th one? A and B are two alloys of gold and copper prepared by mixing metals in the ratio 7 is to 2 and 7 is to 11 respectively. If equal quantities of the alloys are melted to form a third alloy C, then what is the ratio of gold and copper in the C? So what he's saying, he has got first type of alloy in which the ratio of gold to copper is 7 is to 2. He has got second type of alloy in which the ratio of gold to copper is 7 is to 11. So there are two types of alloy which have got two different composition of gold and copper. Okay, he says when the equal quantity of these two are mixed, then there becomes a new alloy which is called as C, and he's asking for whenever these two types of things are mixed up together, he's asking for the resultant alloy has got what composition of gold is to copper. That ratio they are asking for. This is the situation. Okay, so we can do it multiple ways. So let us take the easiest one. Okay, so we can say the alloy A has got gold quantity as how much? The gold quantity with alloy A is how much? Is nothing but 7 divided by sum of ratio terms. That is sum 7 plus 2. That is nothing but 7 by 9. And similarly, the copper quantity in the alloy A is nothing but 2 divided by sum of ratio term, that is 7 plus 2, that is nothing but 2 by 9 part. Okay, so the alloy A has got 2 by 9 part of uh, copper and 7 by 9 part of the gold is there. So let us convert this 7 by 9 and 2 by 9, multiply them by an x, so that this becomes the real quantity now. So now we can assume that the real quantity of gold in the first alloy is 7 by 9 x unit. That unit can be, could be anything, gram, kilogram, milligram, whatever. Okay, and the similarly we can convert this 2 by 9 part into 2 by 9 x weight. So now alloy A, which means now alloy A has got copper part as 2 by 9 x unit. That could be kilogram, milligram, and so on. Similarly, we can convert the alloy B's gold quantity as 7 by 7 plus 11 part. That is nothing but 7 by 18 part. And the copper quantity can be written as 11 divided by 7 plus 11, that is 11 by 18 part. So we can convert this part value into the real time weight. So the gold weight in the alloy B becomes 7 by 18x, or rather we can take it as, yes, we can take it as x only, because he has said that equal quantities have been mixed up. So x value will remain same. Okay, 7 by 18x, and in the alloy B, the copper part should become 11 by 18x. So these are the real time weights now. 7 by 9x, 2 by 9x. These are the gold copper weight in the alloy A, and 7 by 18x and 11 by 18x are the gold copper weight respectively in the alloy B. Now he is saying in the mixture, what should be the golden alloy weight? gold and copper weight. So for that, we need to add the gold part of both the alloys together and to find out the ratio of it with the copper part of both the alloys. So for that, let us add the gold part of both 7 by 9x plus 7 by 18x. That was the gold part in both the alloys when mixed up. It is 2. 7, the copper part in the first mixture was 2 by 9x and the copper part in the next alloy was 11 by 18x. So this will give us the real time ratio. If we add them together, they're going to come down as 21 by 18x is to 15 by 18x, which gives us simply the ratio as 21 is to 15, and which is nothing but 7 is to 5. So that should be the real time ratio of gold is to copper in the resultant mixture, 7 is to 5, which is available in option number C and is the right answer. Now, a milkman has 40 liters of milk. He added 8 liters of water, which is freely available in 40 liters of pure milk. Find the profit percentage of the milkman if he sells the milk at the cost price, that is at rupees 40 per liter only. Okay. So we can understand this question equally. So there are 40 liter of pure milk available. Okay. Let's say the cost price of 1 liter of milk is 1 rupees. So the cost price of 40 liter of this milk will be how much? Simply 40 rupees. So we have assumed 1 liter's cost price is 1 rupee. So 40 liters cost price will be 40 rupees. This is what we have assumed. Now, he says the 8 liter of water which is freely available has been mixed up into it. And one more thing he's saying is that selling will be done on the cost price. So whatever will be the cost price on the same part will be the selling done. How much of the water has been mixed up? They say 8 liter of water is mixed up, okay, which is freely available. 8 liter water is added, okay, is added into it. So the total quantity becomes, or the total volume rather becomes 48 liters. Okay, the total volume available is 48 liters, which is in that there is 40 liter of milk and there is 8 liter of water. The price of 40 liter of milk was cost price was rupees 40 and price of water is nothing but 0 rupees. Okay, so price of water is nothing but 0 rupees. So that means if they are selling the whole liquid at cost price only, that means for 48 liter of the mixture he will be selling that whole mixture at 48 rupees only, because 1 liter's cost price is 1 liter, cost price is 1 rupees. So 1 liter's selling price should be 1 rupees only, because they are saying the selling price and cost price is same. So if 1 liter selling price is 1 rupees only, so 48 liters selling price of 48 liters will be 48 rupees only. So the cost price becomes 40 rupees because the water is free, and selling price becomes 48 rupees. Okay, so the profit of 8 rupees has been earned over a cost price of 40 rupees. So that's how we can calculate the profit percentage. Profit percentage is nothing but profit divided by cost price into 100%. That is what is the profit percentage value, profit percentage expression. So the profit is 8 rupees, cost price is 40 into 100. If you do, we're going to get to 20%. So he, in this particular deal, he is gaining actually 20% of profit, and which is available in option number A. Now, they say a container is full of paint. A person used to draw out 25% of paint and replace it with spirit. He has repeated this same process for 5 times, and thus there were only 2430 gram paint left in the container. The rest of the container is filled with spirit. Then find the initial amount of container. For this, we need to understand the situation. Suppose there in a vessel, there is X liter of pure any substance, of pure any mixture, or pure any chemical, or pure any milk, or pure any anything. Okay, if there is a X liter of something pure in a vessel available, and if Y liter is taken out, okay, if Y liter is taken out, okay, and is replaced by something other than the pure content, something other, okay, it is replaced by something other. It could be water also, it could be spirit also, it could be anything, but not that pure substance which was initially available. And if this step, that Y liter is taken out and replaced, so it is refilled, the same Y liter is refilled with water, let's say. So if this particular process is repeated, this particular process is done n times totally, okay, if this process is done n times, okay, if this process is done n times, then how much pure will be left out? how much pure X will be left out after n such steps have been done will be left out. For this situation, we have a formula. That formula says how much part would be left out of the pure content will be X into 1 minus Y over X to the power n. So this much part, this much pure content would have been left out after n such step have been done. So we can relate this formula to the situation given to us. They say a container is full of paint, so the pure quantity is X liter that is full of paint, and 25% has been drawn out, so that Y part can be related as 25% or 1/4 of part, and then replaced by spirit, and the process is repeated 5 times. That means that in all the process is done 5 times. He has repeated the same process 5 times, so in all the process is done a total of 5 times, and they say the value remains is 2430 grams. So the left out part is 2430 gram is equal to original part is not available with us. That's what we are supposed to find out. Find the initial amount. So let us assume the initial amount to be X only. 1 minus Y over X. How much part has been removed? 25% has been removed. 25% is how much part of the original content is always 1 by 4. 25% nothing but 1 by 4. How many times the process has been done? Total 5 times. So this is how we can relate the formula. And if we want to solve this further, this will give us 2430 is equal to X into 3 by 4 to the power 5. And if we solve this further, the X value finally comes out to be 10.24 of gram. The final value comes out to be 10.24, not gram, rather kilogram. So that is the right answer, 10.24 kilogram, which is available in option number B and is the right answer. Next, two vessels A and B contain mixture of milk and water in the ratio 4:1 and 9:11 respectively. They are mixed in the ratio 3:2. Find the ratio of milk and water in the resultant mixture. So let us understand there is a type of mixture in which the ratio of milk is to water is given out to be 4:1. There is another type of mixture B in the same in the B type of mixture. Milk is to water ratio is little different, that is 9:11. That is the ratio. They are mixed in the ratio 3:2. So the 3 part of A has been taken. So we can write like 3 part of A plus 2 part of B has been taken. 3:2 is the particular ratio in which these two quantities have been drawn out respectively. So 3 part of A has been taken and 2 part of B has been taken. So they are asking for in the resultant mixture, what will be the milk and the water ratio. So let us find out the individual milk and water part. So milk part in the first quantity will be 4 divided by sum of ratio term, that is 5. So milk part in the A quantity will be 4 by 5. Similarly, water part in the milk in the A quantity will be 1 divided by sum of ratio term, that is 5. So 1 by 5 part will be the water. Similarly, milk part in the B type of quantity will be 9 divided by sum of ratio term, that is 9 plus 11, which is 20. That is the milk part in the B type of mixture. And water part in the B mixture will be 11 divided by sum of ratio term, that is 20. So these are the milk and water quantity in the milk in the type A. So this is milk A. This can be written as water A. This is milk B, and this is water B. So these are the four compositions, different available. Now they say 3 part of A is to be taken. So when we want to know the milk part in the resultant mixture, so we'll have to multiply the milk part of A with by 3. So we have to do like 3 times of milk part of A plus 2 part of the milk part of the B is taken. So 2 times of milk part of B. This will be the ultimate milk part, and the ratio of that should be taken with 3 part of the water part of A plus 2 times the water part of B, and that should be giving me the real time ratio of milk to water in the resultant mixture. So let us do it like that. 3 times the milk part in the A, that is going to be 3 into 4 by 5. That is to be added with 2 times the milk part of B, that is nothing but 2 into 9 by 20. That should be the total milk part divided by, we are going for total milk part. Let's dedicate total milk for that. Let's dedicate total water for the total water. Now total water should be 3 times the water part in the first milk, the first mixture, that is A. So that is going to be 3 into 1 by 5 plus the 2 times the water part in the mixture B. So 2 into water part was 11 by 20. So this is how the ratio can be found out. If we solve this further, the ultimate value is coming out to be 33 divided by 17, and which can be written as 33 is to 17. Okay, so that should be the final answer. 33 is to 17, which is available in option number B. Now, as they say, in a mixture of 60 liters, a ratio of milk and water is 2 is to 1. How much more water must be added to make the ratio 1 is to 2? So let us write down here. We have got 60 liter of mixture in which the ratio of milk to water is 2 is to 1. So we can find out the milk part in the mixture. So milk part in the mixture will be the corresponding number with respect to milk is 2. Total mixture is 60. 60 divided by sum of ratio terms, that is nothing but 2 plus 1, that is a ratio of, that is a sum of ratio term multiplied by the milk part is nothing but 2, so multiplied by 2. Similarly, water part can be calculated as total mixture is 60 divided by sum of ratio term, that is 2 plus 1, and how much is the water part corresponding number, that is nothing but 1, so multiplied by 1. If you solve this further, this comes out to be 60 by 3 is 20 into 2. 40 is the 40 liter is the milk part, 40 liter is the milk part, and 60 divided by 320 into 1 is 20 liter is the water part. So this is the original composition. Milk part is 40 liter and water part is 20 liter. This much is originally available. Then they say how much more water to be added to make the ratio of 1 is to 2. So we can write like milk part should remain as it is divided by to new water part. Let us assign that water new water part. The ultimate ratio should come out to be 1 is to 2 now. So how much is the milk part? Milk part remain as it is because there is no adding up or no subtraction in the milk volume has been done, divided by the water part. The original water part was 20 liter. How much water he has added, that we have to find out. So let us assume x liter of water is to be added. X liter of water to be added to give you the composition as 1 is to 2. Let us assume this. So the new water quantity becomes 20 was originally available plus x we added is equal to 1 by 2. And if we solve this equation further, we're going to get our x as, so x can be found out 80 is equal to 20 plus x. So x value comes out to be 60 liters. So if you add 60 liters of water to the original mixture, the ratio of milk is to water will change down to 1 is to 2. So the right answer is say x equal to 60 liter, which is available in option number D, and is the right answer. Now, let us see 24. In what ratio should water and wine be mixed so that by selling the mixture at cost price, a profit of 16.2 by 3% is made? Okay. So one important thing to note down here, that selling price equal to cost price. So if the selling price is equal to cost price, and if you don't increase the any quantity by mixing something free into it, okay, then you will not have any profit, not have any loss. But if you mix something free into it, so the total volume will be changed and total volume will be increased, and whatever quantity you have mixed it into it and which was free to you, that quantity's price will be your profit. Okay, that quantity's price will be your profit only. Okay, let us understand this by a figure also. Suppose we have got a vessel and we have got, let's say, x liter is already available with me, and the price of this x liter is, let's say, x rupees only. And the price of this x liter is x rupees only. So if I sell this at cost price only, so I'm going to sell it at, the selling price will be x rupees only. Cost price is x rupees, selling price will be x rupees only, and I'll have no profit, no loss. But if I increase this x liter quantity by something which is freely available to me, and the volume of that freely available that I have added into the vessel is, let's say, y liter. Okay, and if I mix them, the total quantity now becomes x plus y. So the price, and if I sell it at the cost price only, the price that will come out to be x plus y now. Okay, so how much will be the profit made? Profit is cost price minus selling price. Cost price will be still x rupees because y liter that you have added was free. So cost price is still x rupees and the selling price is x plus y rupees. So profit is nothing but y rupees, and y rupees is the price of that quantity which you have added into it actually. So whatever you add into the original quantity and which is free to you, that the quantity of that thing is your profit only. Okay, so this is understandable. Now what is the question says? Water of and wines ratio is given to us, is to be find out, so that by selling the mixture at cost price, the profit is 16.2 by 3%. So profit is nothing but the added quantity. The profit is nothing but the added quantity value, because that's what is giving you the profit. Otherwise, you would not have any profit because you are selling the things at cost price only. So the quantity added is nothing but your profit. So how much quantity is added? They say 16 2 by 3% quantity is added, which is nothing but 50 by 3%. And if I find out it with 100%, 50 by 3 of 100 will give you the value as 1 by 6. So 1/6 of the quantity has been added, then you are getting the 16 2 by 3% profit. That's what it becomes. So the ratio of so we can say that the ratio of water to wine should be 1 part should be water and 6 parts should be wine. If I add 1 part of water into the total mixture out of the 6 parts, then I'm going to have the profit of 16 2 by 3% only. So that is the real time mixture 1:6, which is available in option number C. Now, a piece of an alloy of two metals A and B weighs 15 grams and costs rupees 150. If the weights of two metals be interchanged, the new alloy would be worth rupees 120. If the price of metal A rupees 6 per gram, find the weight of the other metal in the original price of the alloy. Okay, so what they say is there is a alloy A type, okay, in which the weights, the ratio is not given. So a piece of an alloy of two metals, so this is an alloy rather, okay, and the two metals are mixed up, that is A and B. Their compositions is unknown. Okay, let's say the composition is X is to Y. So if they have a composition X is to Y, the price is 150 rupees. Okay, now, in the similar alloy, they say if the composition is changed, if the weights of the two metals are interchanged, that means the metal A and B earlier had got X is to Y. Now, if the weights are interchanged, that is the ratio is made as Y is to X. In place of X to Y, it has been made to Y is to X. Then they say the price changes to 120 rupees. Then the price becomes 120 rupees. So what we will do, if we add these two types of alloys, what we're gonna say, if the two types of alloy are mixed up, okay, two types of alloy with different compositions are mixed up together, alloy first type and alloy B type is mixed up, then we can easily say, then the mixture will have, then we can easily say the mixture will have, the mixture has 15 grams of metal of both types. Okay, metal of both types of metal will be available. Okay, metal of both the types will be available with us, whose cost will be how much? The cost of that will be 150 was the cost of the first one and 120 is the cost of the next one. So the total cost becomes 270 rupees. So 270 rupees will be the cost of that particular metal, that particular piece of alloy, which has been formed by mixing these two type of composition of alloys. Okay, now in this particular 270 rupees piece, we will have cost of 15 gram of metal A type, 15 gram of metal A will be there, plus similarly 15 gram of metal B is also there, because total piece was of 15 gram only. And if these two 15 grams have been added up, then each will have A type and B type as 15 gram only, because the total sum is always 15. Okay, so 15 gram of A and 15 gram of B we have in this particular mixture, whose price now becomes 270 rupees. Okay, now the type A, if the price of metal A is rupees 6 per gram, the price of metal A is already given to us, so we can put it into here. So 15 gram, if 1 gram's price was 6, so 15 grams price will be 15 into 6. So this will be the price of the first type of metal, plus next type of metal's price is not known to us, so we can assume that as B only. So 15 into, let's say the price of the other metal is B, so 15 into B is should be equal to 270. So if we solve this equation further, we can find out our B, that is how much is the metal type of B available into it. Okay, or rather what is the price of the metal B. So this can be found out by 270 minus 15 into 6 is 90 divided by 15, and which comes out to be how much? 270 minus 90 is going to be 180. 180 by 15 is going to be 12 rupees. Okay, so the metal B has got pricing as 12 rupees. Metal A had got pricing as given in the question itself, 6 rupees. So metal A is cheaper, metal B is dearer. Okay, and what should be the resultant mixture's price? So the resultant mixture is 150. Okay, the resultant mixture's price is, the resultant mixture price is nothing but 150 rupees. In the first composition, the resultant mixture price is 150 rupees only. And how much is the quantity? The quantity is 15 gram as given in the question itself. The price is 150 rupees and the quantity is 15 grams. So what should be the average price? Okay, average price should be The average price can be found out by dividing 150 rupees by 15 gram. That is nothing but 10 rupees. So we have three prices available here. A is the cheaper one, 6 rupees. B is the dearer or the costlier one, which is 12 rupees. And the mixture of these two should give you the 10 rupees as the average price. So this is the mean price available with us. Now we can have our alligation method in the C, in which says C, D, and M, in what ratio they should be mixed up. That's what this gives us. So the ratio becomes D minus M is to M minus C. So let us use this. The cheaper is 6. The dear is 12. The mean is 10. So in what ratio they should be mixed up? 12 minus 10 is 2, and 10 minus 6 is 4. So they should be mixed up in a ratio of 2 is to 4, which is nothing but 1 is to 2 only. So the cheaper type of metal should be taken in the one part, and the dearer type should be taken in the two part. And what they have asked? They have asked, find the weight of the other metal. That is the find of the B. We have to find the weight of the metal B into it. Okay, so the metal B has to be taken in two part out of the total 1 plus 2 3 parts. So the metal part should be 2 divided by metal B should be in the quantity of 2 divided by sum of ratio term, that is 1 plus 2. 2 out of 1 plus 2 into total weight is 15 gram. So out of that 15 gram, how much is the metal B type? That we are finding out here by doing 2 divided by sum of ratio term, that is 1 plus 2. So it gives us 30 divided by 3, that is nothing but 10 grams. So we can easily say that in that 15 gram of piece, 5 gram is the metal of 6 rupees type, and 10 gram is that metal of 12 rupees types. Okay, 10 gram is that metal of 12 rupees type, which is a B type. And that was what asked, that how much is the metal of type B, which is 10 gram. And that is the right answer, which is available in option number C, 10 gram. Now, the average daily wages of staff consisting of supervisors and laborers of a company is rupees 50. So the mean price is given out to be rupees 50. Okay, that is the mean price. The average wages of supervisors is rupees 150. So supervisor are paid higher. So we can take that as a dearer price. Dearer price is 150 rupees. And the laborer price is a little on the cheaper side. That is rupees 40 only. So laborer's price is nothing but the cheaper price. That is nothing but 40 rupees per day. So they are asking the number of supervisor is 15, the number of laborers of the company. So we can again relate the situation by our allegation method, cheaper part and dearer part and the mean part. What should be the ratio of these two? So that the cheaper part and dearer part should have the mean price as their average price. The ratio should be D minus M to M minus C. So we can use this allegation method to find out the number of laborers in the company. So the cheaper part is the cheaper labor, that is rupees 40. The dearer part is the higher costlier wage, that is nothing but rupees 150. So 40 and 150 being mixed up, so that the mean price or the mean wages that is to be given to all the worker, they have already mentioned the mean or the average of daily staff members wages is rupees 50. So the mean should be 50. What should be the ratio coming out? It has to be 150 minus 50 is 100 on one side, and 50 minus 40 is 10 on one side. Now the ratio of, so this was the wages of our supervisor. This was the wages of labor. So the labor should be the number of workers in the laborer class and in the supervisor class should be 10 is to 1. So this is the supervisor class. 100 is to 10 is nothing but 10 is to 1. So if the 10 part is the labor, then supervisor should be 1, or we can say there should be one supervisor over 10 such labors. How many supervisor do we have? 15. So we can relate the situation as labor is to supervisor should be 10 is to 1, and the labor part is not given to us. We are supposed to find out the supervisor part is already given to us. So let's say labor part is unknown, supervisor part is 15, should be equal to 10 is to 1. Okay, so what should be the labor price? Labor price should be nothing but 10 into 15, which is 150. So the number of labor to maintain the average wage as 50 should be 150, which is available in option number A and is the right answer. Okay. A shopkeeper has 100 kgs of tea. He sells a part of it at 20% profit and the rest at 5% loss. If his overall profit is 10%, find the quantity for each part. So again, this question can be done by the allegation method. And the allegation method is cheaper part and costlier part should be mixed in a certain ratio to give the mean price. And what should be that ratio? That ratio should be D minus M is to M minus C. Okay. So In the cheaper side, we can say the loss part. Okay, the cheaper side is nothing but the loss part, dearer side is nothing but the profit part, and the mean price is nothing but the overall profit or loss, that is 10%. So that should be the mean price. So we can relate the situation like cheaper part is nothing but the 5% loss. So if it is 5% loss, we will write -5 for that. And dearer part is nothing but the 20% profit. So if it is 20% profit, we'll just write 20 for it, or rather plus 20. The overall, there has been a profit of 10%. So we'll write plus 10 for it, or simply 10 for it. Okay. And what should be the ratio? Okay. If he's got 100 kg of tea, then what should be the ratio of each type of tea over there? Okay, the quantity of each part of tea should be there. So the ratio will come out to be 20 minus 10 is 10 here, and 10 minus minus 5. But we are doing here 10 minus minus 5. Okay, because the loss has been -5. So it becomes 15. So what should be the ratio of the loss part and the profit part is, the loss part value is 10, profit part value is 15. So 10 is to 15 is nothing but 2 is to 3. Okay, 10 is to 15 is nothing but 2 is to 3. So loss part should be 2 part and the profit part should be 3 part. Total weight is how much? 100 of kg. And what we are supposed to find out? Find the quantity for each part. So let us find out the loss part first. Loss part quantity can be found out by total quantity is 100 divided by sum of loss part and the profit part is 2 plus 3 multiplied by the corresponding number of the loss part, which is 2 multiplied by 2, which gives us the value as 40 rupees, rather 40 kgs. So this is the loss part quantity, 40 kg. Similarly, the profit part quantity can be found out by the total weight is 100 divided by sum of the both parts, that is 2 plus 3 into the profit part was 3 part. So this can be found out as 60 kg. So these are the two parts, 40 kg and 60 kg. Okay, two parts available to us is 40 kg and 60 kg. They are asking find the quantity, they're asking for the find the quantity for the loss part, and the quantity for the loss part is nothing but 40 kg, which is available in option number D. It's available in option number D. Loss part is 40 kgs. Now, 91 liters of a mixture contains water and vinegar in the ratio 8 is to 5. How much more vinegar is to be added to get a new mixture containing water and vinegar as 7 is to 9? So let us do it simply. Water content in the mixture. How much is the water content in the mixture? See, the ratio is, so if we talk about the mixture, the ratio of water to vinegar is given out to be 8 is to 5. Okay, that is 8 parts should be water and 5 parts should be vinegar. The resultant mixture, whatever addition that we do some addition here and the replacement here. After that addition, the new mixture N should have the same ratio of water to vinegar now as 7 is to 9. That's what has been asked. Okay, so let us find out the water part in the original mixture first. So it has to be, water part is 8, total mixture is 91 liter divided by sum of ratio terms, that is 8 plus 5, water part and vinegar part, into, because we are finding out the water part, so we need to multiply this fraction is expression by 8. That was the original water part, into 8. If we solve this out, this comes out to be 56 liters. So the water part in the mixture is 56 liter. Similarly, we can find out the vinegar part. Total mixture is 91 divided by sum of both the parts, water and vinegar, multiplied by the vinegar parts number, that is 5. So multiplied by 5. If we solve this, this comes out to be 35 liters. So the vinegar part becomes 35 liter, water part becomes 50 liter. This is the original situation. Then they say how much more vinegar is to be added. So we'll assume something. Let's say X liter of vinegar to be added. X liter of vinegar is to be added. Okay, if we are supposed to add X liter of vinegar into it to give away the need ratio as 7 is to 9. So now the water part is still the same. So water part to new vinegar part. Okay, that's what we are finding out. They want the water part to new vinegar part to be 7 by 9. How much is the water part? Water part is as it is because there is no addition and subtraction in the water part. So 56 as it is. Vinegar part is, the original vinegar was 35. How much vinegar more has been added? We have assumed it to be X. So now we are supposed to solve this particular expression. If we solve this, we're going to get to our answer. We can cut the things here also. 7, 8 ja 56. Then the simple expression can come out. So it is going to be, if we solve this, X value is coming out to be finally 37 liter. Okay, so if we add 37 liter of vinegar into the mixture of 91 liter, we're going to have the composition of water and vinegar changed to 7 is to 9. So the answer is 37 liter available in option number B. Now, A vessel contains a mixture of grape juice and apple juice in the ratio 3:2. Okay, so vessel contains, so the mixture is the two juices are mixed up, grape juice and apple juice. The composition is 3:2. When 2 liters of this is drawn out and replaced by apple juice, so out of this thing, minus 2 liter has been replaced and replaced by minus 2 liter has been drawn out and replaced by 2 liter of apple juice only. 2 liter of apple juice. Then they say the new ratio of the juices becomes 2:3. So the new mixture should have the grape to apple ratio changed to 2:3. Then say find the quantity of grape juice in the vessel before the replacement. This is what is the situation. Okay, so let us do it simply. Let's say the vessel contains 3x and 2x. Okay, so what we'll assume, let the grape part in the original content is 3x liter, and similarly, let us assume the apple part is 2x liters. Now we have converted the ratio terms into the real time volumes 3x and 2x. Okay, so now we are supposed to find out quantity of grape juice in the mixture. Okay, so how much will be the quantity of grape juice in the new mixture? Okay, for that we are supposed to know the mixture has got quantity of apple juice in the new mixture. They want to be 2:3. Okay, and 2 liter has been removed out only. So whatever is removed from the original mixture, so the similar composition is gone out from the in the replaced part also. So in the 2 liter that has been removed, what should be the composition in that 2 liter? The composition remains 3:2 only. Okay, so now we can say the quantity of apple juice in the mixture will become, how much will become in the mixture, in the new mixture, the grape juice will be how much? Grapes juice will be how much? The originally grape juice were 3x. Okay, how much has been, before finding out the new mixture, we are supposed to find out how much has been reduced, because the 2 liter was replaced, 2 liter were removed first. So if the 2 liter is removed, how much part of the grape juice has gone? The 2 liter is the total quantity divided by sum of the ratio terms. Ratio term is 3 plus 2 multiplied by grape juice part was grape juice part was 2 part. Okay, initially they said there has to be uh, the grape juice part was 3 part rather. So this has to be the removal of grape juice. Okay, similarly if we solve this further, this comes out to be 3x minus 6 by 5 liter. So this much of the grape juice is left out after 2 liter has been removed. Now, similarly, we'll find out what is the apple. What is the apple juice left out when the 2 liter has been removed? So the original apple was 2x minus how much apple juice has been removed when 2 liter is removed? Total value is 2 divided by sum of ratio term, that is 3 plus 2 into the apple part was 2. So this gives you 3x, rather 2x minus 4 by 5. 2x minus 4 by 5. So this much has been left out after the replacement has been done. And whenever the replacement happens, so the original quantity, that the left out quantity has got the same ratio as it was earlier. Okay, the ratio of apple to grape or grape to apple juice will have the same value set as it was originally available. So the left out part values are these. So the grape part to the apple part will still remain to be 2 by 3 as in the original content. Okay, grape part to the apple part will remain as it is, as it was available in the original content. That means 3x minus 6 by 5 divided by 2x minus 4 by 5. So the left out part will be remaining as 2 by 3 only. So it will maintain the same ratio. If we solve this further, we're going to have to do cross multiply. If we do this, 3 into 3x minus 6 by 5 is equal to 2 into 2x minus 4 by 5. If we solve this further, this comes out to be 45x minus 18 is 12 plus 20x. If we solve this further, x value comes out to be 30 by 65. So this was the x value that we have found out. Now what they have asked, they have not asked for the quantity after the replacement has been also done. They have asked for, what they asked for, to find the quantity of grape juice in the vessel before the replacement has been done. So initially, how much was the grape juice content? The grape juice content initially was 3x. Okay, that's what we have assumed. And now we have found out the x value. So the original grape juice content was nothing but 3 into the x value, that is 30 by 65. If we solve this further, this comes out to be 1.38 liters of the grape juice available initially. So that becomes the right answer. Initially, there was 1.38 liters of juice available in the vessel, and that is available in option number D and is the right answer. Now, let's say the next one. Two chapatis of wheat and gram flour contains 296 calories and 196 calories respectively. If the in the mixture of both wheat and gram flour, one chapati contains 108 calories, then find the percentage of wheat flour in the mixture. So first thing that we understood is two chapatis have got 296. Two chapatis of, let's say, which type? Wheat type. Two chapatis of wheat type has got 296 calories. So one chapati of wheat will have how much? Half of it. That is nothing but 148 of calorie. Okay, 148 of calorie. Similarly, two chapatis of the gram flour contains 196 calories. So one chapati of gram flour will contain how much? Just half of it. That is nothing but 98 calories. No, now the 98 calories flour has been mixed up with 140 calories flour to give away the resultant mean flour calorie value as 108 for the one chapati case. So the 98 calorie case can be treated as the cheaper one, 148 can be treated as the dearer one, and the mean price can be treated as 108. So we can go to our allegation method, which is cheaper, dearer, mean, and what should be the ratio? The ratio should be D minus M, as explained in the earlier questions also, and the M minus C. So what should be the ratio between cheaper part and the dearer part to be mixed up to give away the mean price as M? The ratio should be D minus M is to M minus C. So we have got the cheaper value as 98, the dearer, the costlier value as 148, the mean price that should come out to be 108. If we solve this further, 148 minus 108 is nothing but 40, and the mean part 108 minus 98 uh, is nothing but 10. So the ratio of the 98 calorie flour to the 148 calorie flour should be 4 is to 1. Okay, so we can say that out there are total 5 parts here. So we are supposed to find out the percentage of wheat flour into it. So wheat flour percentage can be found out by wheat part divided by the total part into 100%. And how much is the wheat part? Wheat part is the flour with the cheaper with the higher price, that was 148 one. So the dearer price is 1, okay, divided by the part of the wheat flour has come out to be 1, so the wheat part has been kept as 1 in the numerator, divided by total part is how much? 4 plus 1, that is the total part, that is number 5. 1 by 5 into 100%, and that comes out to be simply 20%. So the ratio or the part of wheat flour in the total mixture is 20% out of the total 100%, and which is available in option number A. 20% is the right answer. Now, let us see the 31. They say a vessel contains mixture of liquids A and B in the ratio 3 is to 2. When 20 liter of mixture is taken out and replaced by 20 liter of liquid B, the ratio changes to 1 is to 4. Okay, so originally the composition was in the mixture, the composition of A and B was nothing but 3 is to 2. Okay, the 20 liter has been removed first and added 20 liter of the 20 liter is taken out and replaced by 20 liter of liquid B. So 20 liter of B has been added up, 20 liter of A has been removed, and 20 liter of B has been added up. And then the composition in the mixture, the ratio changes to 1 is to 4. In the new mixture, the ratio of A is to B changes to 1 is to 4. So they are asking how many liters of liquid A was there initially in the present vessel. Okay, so let us do it simply. First of all, we'll find out what should be the percentage of liquid B present in the vessel initially. Okay, but we'll find out initially at the very beginning percentage of liquid B. Okay, percentage of liquid B can be found out. B has got 2 part out of the total 2 plus 3, 5 parts. So it can be found out by 2 divided by sum of ratio term, that is 2 plus 3. Okay, and percentage value is 100%. So 2 out of 5 part was your this particular B. So that is nothing but 2 by 5 part of B, that is 2 by 5 100% is nothing but 40%. So type B in the original content was 40%. So obviously the type A will be 60%. Okay. Now what he has done? He has done is 20 liter he has removed of A and 20 liter of B has been added up. Okay. So percentage of liquid B finally present will be 80%. How much will the final percentage? Okay, how much will the final percentage of be? Originally it was 40%, then 20% has been removed and replaced. Okay, so the part has changed to, they say, 4 out of 4. 1:4 has been the composition in the mixture. So we can write like percentage of liquid B finally present in the vessel will be, see, percent the B part in the mixture, new mixture, will be 4 part. So 4 divided by, and A part will be nothing but 1 plus 4. The total mixture will be 1 plus 4 into 100%, and that is how much? That is nothing but 80%. So this will be the final position, or final percentage of liquid B in the new mixture. That will become out to be 80% of it. Okay, now, so now we can assume that there is a method called as, which is cheaper, dearer, mean, and the ratio it gives to us cheaper, dearer, and mean, and it gives us the ratio. What has happened is, the second solution, liquid B, which is being mixed up, and it has 100% of liquid B. Okay, so from the second solution, what is being mixed up, they say, is taken out and replaced by 20 liters of liquid B only. So the liquid B that is being mixed up has got 100% of liquid B, no mixing. And the liquid A in which this is being mixed up has got 40% of liquid B. So the cheaper part can be taken as 40%, and the dearer part can be taken as 100% of B. And what should be the resultant composition coming out? The final percentage of B that has become in the composition is 80%. So 80% should be the final composition. Okay, 40% was the B quantity in the initial one. 100% is being mixed up, because they say all B is mixed up. So all B will have 100% of B, and the mean quantity becomes as 80%. So we can find out the ratio of them. This is coming 20. 80 minus 40 is 40. So 20 is to 40 is nothing but 1 is to 2. Okay, the 20 is to 40 is become as 1 is to 2. That means the cheaper part should be 20, or the 40% price should be 1 part, and that is being mixed up has to be 2 part. What had they asked for us? How many liter liquid A was there initially present in the vessel? So let us take it further. Now 1 is to 2 is the ratio between the already present liquid B and the liquid B that has been added further. Now the total quantity that will become will how much? Total quantity that will become will be 10 plus 20 is equal to 30 liter. Okay, where have this 10 and 20 come? See, the quantity of B that was mixed, B which was mixed was 20 liter. Okay, the B which was mixed was 20 liter, and this 20 liter that has been mixed has come out to be 2 part of something. Okay, so what should be the original part? B original should be half of it, that is 10 liters. Okay, so that's why if we add them together, the new B quantity, the total quantity of liquid initially present in the vessel should be how much? 20 plus 10, that is 30 liters. So we are supposed to find out the quantity of A. Quantity of B we have found out as 30 liter, but in the question we are supposed to find out the quantity of A, and quantity of A can be found out by, what is the composition? There is 3 part of it divided by 2 plus 3, because that was the original composition only. 3 is to 2 was the composition of A is to B. So that's what we see. A is to B has got 3 is to 2 only. So that's what we are again doing here. Here, 3 part of A was available. The sum of ratio term was 2 plus 3 multiplied by how much was the total mixture? The total mixture was nothing but 30. If you solve this, this comes out to be 18 of liters. So that means A in the original vessel was nothing but 18 liters, which is available in option number B, and becomes the right answer for us. Okay, let us see 32. I have rupees 33 in my pocket consisting of 50 paisa and 25 paisa. Thus, there are totally 72 coins in my pocket. Find the number of 25 paisa coins. So we can again utilize the method of mixing or alligation. C, D, M, and C is the first type of quantity, D is the costlier type of quantity, and M is the mean price that should become by mixing, and in what ratio they should be mixed up to give you the mean price as M. That ratio is nothing but D minus M is to M minus C. Okay, is to M minus C. We can make use of this fact where what can it become? First of all, we are finding the mean price. Okay, so how much is the total quantity? Total price. The total price of the whole bag of the whole packet is rupees 33. okay, divided by what is the total number of coins. Total number of coins are 72. So each coin has got mean price as coins mean price. Okay, the average price of each coin is how much? 3300 paisa, because 1 rupees is equal to 100 paise. So 33 rupees will be having 3300 paise divided by 72. If we do this, this comes out to be 45.83 paisa. So this is the mean price of each coin. Average price of each coin is 45.83 paisa. Whereas we have got a mixing. What mixing we have got? We have got cheaper price, that is 25 paisa is the cheaper one, 50 paisa is the dearer one. So we can mix them in the allocation method. Cheaper price is 25, dearer price is 50, and the resultant mixture should have a price of 45.83. That is the mean price. In what ratio they should be mixed up? They would have been mixed up inside is the subtraction of 50 minus 45.83, that is nothing but 4.167, and m minus c. So difference of 45.83 minus 25 is going to be 20.83, and which is nothing, the ratio is 1 is to 5. The ratio between 4.167 and 20.83 is nothing but 1 is to 5. So 25 paisa coin should be one part and 50 paisa coin should be 5 part of that. That is 5 times of 25 paisa coin. How many total coins do we have got? We have got 72 coins, and there what is being asked to find the number of 25 paisa coins, and 25 paisa coin have got a corresponding number as 1. So number of 25 paisa coin can be calculated as how we can calculate that? Total number of coins were 72 divided by sum of ratio terms. Ratio terms are 1 plus 5 multiplied by the corresponding number of 25 paisa, that is 1. If we solve this further, this is going to be 72 by 6, that is nothing but 12 coins in there. Okay, that is nothing but 12 coins in there. So rupees 25 paisa coins are 12 in number, and that is available in option number C, and that becomes the right answer also. Okay, so the question says tea worth rupees 126 per kg and rupees 135 per kg are mixed with a third variety in the ratio 1 is to 1 is to 2. If the mixture is worth rupees 153 per kg, the price of the third variety per kg will be. Okay, so we have seen a few methods in which the two quantities get mixed up, and to find out a ratio, suppose the one quantity is a little cheaper, another one is a dearer one, and to get the mean price, that is already given in most of the questions. To get the mean price, what should be the ratio of the cheaper one to the dearer one to be mixed up? We found out that ratio by d minus m is to m minus c. So the ratio in which the cheaper one and the dearer one to be mixed up to get the mean price as the mean is the m is the ratio d minus m is to m minus c. But this particular method we have seen for two quantities or two types of solutions or two mixtures to be done. When there is three mixtures to be done, so the method is slightly changed. What can be done is that we can find out the mean price of the first two mixtures. Okay, we can find out the mean price of the first two mixture, that is 126 and 135 rupees per kg, and that mean price of these two mixture can be treated as one of the prices of the two quantity, and the other the other quantity is nothing but the third variety. So the mean of the first two is treated as the first quantity, the first mixture, and price of the third quantity is treated as the second mixture, and the same method is again applicable. So to understand that, we are supposed to find out the mean of the first two quantities price that is given. So we can say the average or the mean of the first two quantities, the first two T types, the price is, so the mean price will be the type A has got the T of first type is 126 rupees, T of the second type is 135 rupees. So the mean price should be A plus B divided by 2, which gives us the mean price as 130.50. So now the T, now we'll treat this question as the T of the type 130.50 rupees per kg is being mixed up with the third variety, which will be treated as the second for the case of alligation method. Now, here the question is, let the third price to be assumed as x. Let us assume the third variety of T as x rupees per kg. The price of the third variety of the T is, let us say, x rupees per kg. The first variety that has become the new first variety is the price is 130.450 per kg. Okay, and what about the quantity ratio between these two? So what we have seen is we have seen the ratio of the first quantity and the second quantity is 1 is to 1, and the third quantity has got the ratio 2. But when we have found out the mean of the first and second, so both the quantities have been added in the equal proportion. That means the part of the t of the first type and the part of the t of the second type has been added to give us the two part in the ratio 1 is to 1 is to 2, and the third variety is mixed in the two part. So ultimate ratio between the mean of the first two and the third variety type is 2 is to 2. That is nothing but 1 is to 1. So what we can understand is the in the chart, the ratio, the typical ratio that we want to find out every time is nothing but 1 is to 1. That is the ratio between the mean of the first two quantity and the third quantity. So now we can use the values in the chart. The cheaper, dearer, and mean. We have got the cheaper, dearer, and the mean. Okay. So let us see. So the one type of quantity is has got the price as 130.50 rupees per kg. Another type of quantity, we have assumed the price of the third variety is, let's say, X. The mean price that should become is, okay, we are supposed to find out the mean price. The mean price is already given. The T should worth, after the mixture is done, the T should worth 153 rupees. So that is the mixed price. That is the mean price rather. And the ratio to come out should be 1 is to 1 because that's what we have found out here. And what is the difference coming? The first difference is coming out to be X minus 153, and to be mixed up 153 minus 130.50, if you solve, that is 22.50. So this has to be the ratio, and this ratio we have already calculated to be 1 is to 1. Okay, so now we can solve this. X minus 53, rather x minus 153 divided by 22.50 should be 1 by 1. The ratio should be similar. So we can find out x minus 153 as 22.50. So here where the x value comes out to be 175.50 rupees. Okay, so the third variety is costing to be 170.50 to give you the situation of 1 is to 1 is to 2 in the new mixture. So that is the answer, 175.50, available in option number B. Now, 34. Three bottles contain equal amount of mixture of milk and water in the ratio 3 is to 2, 2 is to 3, and 7 is to 5. So let's say the first type of bottle is A. The ratio of milk and water is given as 3 is to 2. Let's say the second variety is B. The ratio of milk to water is given as 2 is to 3. Third variety is C. The ratio of milk and water is given as milk is to water is given as 7 is to 5. So these are the three types of bottles available with us, three types of mixture, and their different composition of milk and water is given in the question. What they say, if all the solutions are mixed together, and mind you, all the bottles contain equal amount, so the ratio can be found out as equal. So if all these things are mixed up, then we are supposed to find out the milk and water ratio in the final solution. Okay, that's what is the question ultimately. So let us find out the milk and water part of each and every quantity, each and every type of solution. Okay, so milk part in the first quantity is nothing but the milk part is 3 divided by sum of the ratio term, that is t plus 2, which is giving us 3 by 5. Okay, now the water quantity in the first one is nothing but 2 is the water part. Total sum of ratio is 3 plus 2, so it's going to be 2 by 5. So milk part in the first one is 3 by 5. Milk part in the first one is, water part in the first one is 2 by 5. Now let us find out the milk part in the second one. So the number is 2 and the sum of ratio term is 2 plus 3, so it comes out to be 2 by 5. The milk part in the second type of mixture. Water part in the second type of mixture, 3 is the corresponding number divided by sum of ratio terms, so it comes out to be 3 by 5 is the water part in the second type of mixture. Similarly, we can find out for this 7 divided by 7 plus 5, that is nothing but 7 by 12, and similarly 5 divided by 7 plus 5 again, which is nothing but 5 by 12. So these three are the milk composition. If you notice, this is the milk, this is milk composition, this is milk composition, and these three are the water composition. Now they say they are being mixed up, and after the mixing, they want us to find out what is the respective ratio now of milk is to water. So milk is to water in the mixture is found, can be found out by adding the mixed milk part together. So the 3 by 5 is the first milk part, 2 by 5 is the second milk part, and 7 by 12 is the third milk part. Total milk part is this much. What about the total water part? 2 by 5 is the first water part, 3 by 5 is the second water part, and 5 by 12 is the third water part. So if you add it together, this comes out to be ultimately 19 by 12 divided by 17 by 12. And if you solve this further, this comes out to be ultimately 19 by 17. So that should be the ratio between milk and water part in the resultant mixture, that is 19:17, which is available in option number D, and that is the right answer. Now, a container is full of milk. One third of milk is taken out and it replaced by same quantity of water. Then again one third is taken out and replaced by same quantity, and the process is done repeated 4 times. Okay, has been done 4 times. If 16 liter of milk is left in the container at the end of the fourth operation, find the capacity of the container. Okay, so we have a similar situation where we have got a formula. What is that situation? If X liter of pure something is available somewhere, then if Y liter is removed and replaced, 5 liter is replaced by some other quantity, 5 liter is replaced by some other solution, and this particular process replacement, Y liter removal and adding of Y liter again by some other solution, if this particular process is done total of n times, then after n times such steps of removing out the 5 Y liter of the mixture and adding back the Y liter of some other solution, if this is repeated, if this is done total n times, then after those n times, the remaining pure part of x, okay, the remaining pure part of x that remains after n such steps is nothing but x multiplied by 1 minus y over x to the power n. So this is the same situation in front of us that is happening in the question. What they say, full of milk, one third of milk is taken out. So y over x can be treated as 1 by 3. Okay, so now we can put the values inside, and they say replace by same quantity. The process is done 4 times, so n value can be treated as 4. The remaining part remains, the pure milk remains 16 liter, so the x can be treated as, the remaining part can be treated as 16. So what we can write here is 16 is equal to x value was unknown, the pure pulp originally available is the value is not given, divided by 1 minus y over x is one third as they say, so it has to be 1 by 3, and the process is done total of n times, that is 4 times. If you solve this equation further, this gives us 16 is equal to x into 2 by 3 to the power 4. Okay, if we solve this further, this gives us the result as x is equal to 81 liters. Okay, so the originally the container had got 81 liter of milk. That's what they asked. Find the capacity of the container. The capacity of the container is 81 liters only, because the container was initially full of the milk, and the full milk was available was 81 liters. So that's what is the capacity of the container also becomes. Right answer is 81 liters. Okay. Let us have next one. A 5 kg of metal contains 1 by 6 of gold and the rest is silver. Another 6 kg of metal contains 1 by 7 of gold and the rest is silver. Then the ratio of gold and silver in the mixture of these two metals. Okay. So there are two types of metal over there. So let us say the first metal is A, in which the composition and A is of 5 kg. Okay, and the composition of milk to water is, the gold to silver is 1/6 part is gold. Okay, 1/6 part is gold, to silver part should be how much? 1 minus 1 by 6, that is 5 by 6 part should be silver. Similarly, in the B type, in the another type of metal, there is which is 6 kg in weight. Okay, what is the ratio of gold to silver? They say in the 6 kg gold is 1 by 7 part. So how much should be the silver part? That is 1 minus 1 by 7. That is nothing but 6 by 7 should be the silver part. So, okay, so these are the parts available: 1 by 6, 5 by 6, gold, silver in the first one, 1 by 7 and 6 by 7 in the gold and silver in the second one. And then they say they are mixed up together. Now, so we are supposed to find out the individual weights. So let us find out the weight of gold. Okay, weight of gold in the first type of metal, which was 5 kg in weight. So the part is 1 kg. Okay, gold to silver, and they say 1 by 6 of the gold and rest is silver. So weight of gold in 5 kg will be 1 by 6 or into 5. That is 5 kg is the whole weight. That is nothing but 5 by 6 kg. Similarly, silver part weight will be 5 by 6 into the total weight is 6 kg. So 5 by 6 into 6, nothing but 30 by 6. That is nothing but 5 kg. Okay, that is nothing but 5 by 6 into 6 has to be done. So this 5 by 6 into 5 has to be done. Okay, 5 kg is the total weight and 5 by 6 is the part available. So this has to be not 30 by 6, rather 25 by 6 kg. Now weight of the gold in the second one will be 1 by 7 part. out of the 6 kg. So how much it should be? It should be simply 6 by 7 of kg. The gold part should be 6 into 1 by 7, that is 6 by 7 kg. Silver part in the second one will be nothing but 6 by 7 of the wholes. The whole value is 6 kg, so it is going to be 36 by 7 kg. So these are the weights of the gold and silver in the two types of metal available to us. Okay, now they say if they are mixed up, what is the composition of the gold and silver in the resultant mixture? So if we want to find out that, then we can add the gold part and the silver part together, and add the gold part and the silver part and find out the ratio. So that we call it as total weight of gold divided by total weight of silver. So let us add the gold part. Gold part is 5 by 6 and 6 by 7. So we need to add 5 by 6 plus 6 by 7. That is the gold part, and that has to find out the ratio with the silver part. The silver part is nothing but 25 by 6 plus 36 by 7. If we add them together, 25 by 6 plus 36 by 7. So if we solve this, we can get the value of the ratio of the weight of the gold, weight to the gold. So the upper part comes out to be 71 by 42. The lower part comes out to be 391 by, this is 391 by 42 again. So the ratio ultimately becomes 71 divided by 391. So the ultimate ratio becomes as gold to silver ratio becomes 71 is to 391, and that should be the final answer. 71 is to 391, which is available in option number A. That is the right answer. Next, how much water must be added to a jar which contains 36 liter of vinegar at a cost rupees 18 per liter, so that the cost of vinegar is reduced to 12 rupees per liter? This is what is the question. Now, what is the situation? 36 liter of vinegar is there, and in this 36 liter of vinegar, water is to be added. Okay, so let us do what? So what is that he's saying? 36 liter of vinegar, so, and water is added, and water is available at free. Okay, water is available at free, and which has to be added. So we have a method of adding up two different prices quantity, and in that particular method, if the cheaper one is added with the dearer one and the mean price is to be maintained as m, then the ratio should be d minus m is to m minus c. That should be the ratio. Okay, this is what is the method available with us. Cheaper part in our situation is the water part, which has got zero price. Okay, which has got the zero price. The so C part is nothing but the water. D part is nothing but the vinegar's price. Okay, they say to a jar which contains 36 liter of vinegar at cost rupees 18 rupees per liter. So the costlier part is the 18 price, that is the vinegar. The dearer part should be 18. Okay, water should be available free of cost, so that should be 0. And the mean price they want to be, the mean price of the mixture they want to be 12 rupees per liter, so that should be the mean value 12. So if we put the values like that, the cheaper part is 0 rupees per liter. The dearer part is the vinegar price, 18 rupees per liter. The mean price we want of the mixture to be 12. And what should be the ratio? The ratio should be D minus M. 12 minus 18 minus 12, that should be 6 here. And 12 minus 0 should be a 12 here. What is the ratio of this water to the vinegar comes out is 1 is to 2. So the ratio of water to vinegar that comes out is 1 is to 2. Now what we are supposed to find out? How much water is added to it. So we can say how much water to be added. Total was 36 liter, and water added has to be in the ratio 1 is to 2. So 36 divided by 2, that should be the water value that is to be added, which is nothing but 18 liter. Okay, 18 liter should be the water added, okay, to the vinegar to reduce the cost from 18 to rupees 12, because 36 liter was the total composition and it has to be distributed in 1 by 2, where the one part is the water and we want to know the water part only. So what will be the water part? Nothing but 36 divided by the half part of it, which is 36 divided by 2, which is nothing but 18 liters. So that should be the answer only. 18 liter of water should be added to give you the reduced price as 12 rupees. Now, the average height of 20 females in the group is this much, 5.03, and that of 15 males is 5.10. Find the average height of both the groups of the boys and girls together. Okay, now here they say the male is to female ratio is how much? Male is to female ratio, they say that there are 20 males, rather the female is to male ratio. What is the female is to male ratio? There are 20 females, and how many males are there? There are 15 males. So female is to male ratio is nothing but 4 is to 3. That is the female is to male ratio that is already given to us. And there is a the number The average height of the female is 5.03. Average height of male is 5.10. So we have a method of mixing together which is cheaper, dearer, mean, and the ratio comes out to be D minus M and M minus C. We have this method which we are continuously following for every question. Now this question can also be done using that method. How we can do that? The cheaper part can be treated as the lesser value, that is the female's height, which is 5.03. So let us write 5.03 on the cheaper side. Dearer part is the costlier part, which is nothing but the average height of the 15 males, that is 5.10 is the costlier part, 5.10. And they say average height of both the groups to be together is to be found out. So that average is nothing but the mean. So that mean is unknown. Let us write that mean as M only. Okay, this has to be maintained. And in what ratio these male and female should be there so that the average weight is M, and that particular ratio we have already found out. What is that ratio? Female is to male is 4 is to 3. This was of the female height. This was the male height. Female is to male has to be 4 is to 3. So we already know the ratio 4 is to 3. We already know their ratio. Now using this, we can find out the M value. So what should be the case? The ratio should be D minus M, that is 5.10 minus M. That should be the 4 corresponding to the 4 part, and M minus 5.03, that should be corresponding to the male part rather. So then we can use this into an equation. What we can do, see 5.1 minus M divided by M minus 5.03 should be the ratio as 4 by 3. Then we can cross multiply things. If we cross multiply, we're going to get 15.3 minus 3x minus 3M rather, because the mean price is M, is equal to 4M minus 20.12. Okay, if we solve this together, then we're going to get M value is coming out to be 5.06. So that should be the mean weight of the overall group irrespective of their gender. The answer comes out to be the mean weight is 5.06, which is available in option number C and is the right answer. Okay, let's have the next question. A solution of lime and soda has 6% of lime. Another has got 2% of lime. How many liters of the second solution must be mixed with the 9 liter of the first one to make the solution containing 5% of lime? So two different mixtures with two different composition of lime into it, and the second mixtures composition, the second mixtures quantity to be removed, to be replaced in the first mixture of 9 liter to maintain the ratio, or rather maintain the percentage to be 5% is to be found out. So what we can do, again we can have the method of cheaper, dearer, mean, and the ratio between them should be D minus M to M minus C. Again we can utilize this method where the cheaper part is that part where the lime concentration is lesser, and the dearer part, the costlier part, is that part in which the lime concentration is higher. And the mean price that we want to make of the solution is that particular concentration which we want our mixture to have, that is 5%. Okay, so on the cheaper part we can write 2%, on the higher part we can write 6%, the mean part we want to make it as 5. So what should be the composition, what should be the ratio? Okay, let us find out the ratio can be found out by 6 minus 5, 1 here, and 5 minus 2, 3 here. So the concentration or the ratio of the 2% type and the 6% type should be 1 is to 3. Okay, now as they say, how many liter of second solution was 2% type. So this volume is unknown, let's say X. The 2% type volume is unknown. How many liter of the second solution type, and the second solution he mentioned was of 2% type. So this is unknown to be mixed up with the 9 liter of the first solution. First solution was of 6% type. So 6% type's volume is already given as 9 liter. So whatever ratio X is to 9 liter holds, the similar ratio is 1 is to 3. So we are supposed to find out. So we can write X by 9 is 1 by 3, which gives us X value as nothing but 3 liters. So how much of the second solution to be mixed up with the 9 liter of the first solution is nothing but 3 liters, and that is the right answer, which is available in option number C, becomes the right answer for us. Okay. Next question. How many kilogram of tea worth rupees 25 to be mixed up with 30 kg of tea worth rupees 30 per kg. So the quantity is 30 kg, the price is 30 rupees. So we can treat the cheaper cost is 25, the dearer cost is 30, so that the selling the blended variety at rupees 30 per kg, there should be a gain of 10%. So first of all, we need to find out the cost price of the mixture. Selling price of the mixture is given out to be, selling price of the mixture is given out to be, there's no direct selling price they have given. Yes, they have given the direct selling price. Selling price of the mixture, the selling the blended variety at rupees 30 per kg. So the selling price of the mixture is rupees 30. How much is the gain to have? The gain to have is nothing but 10% gain. Okay, by that we need to first find out the cost price of the mixture. Okay, so cost price formula to find out the cost price when the selling price and the gain percent is given is nothing but 100 divided by 100 plus gain percent multiplied by selling price. So we can find out the cost price of the mixture rather. 100 divided by how much is the gain percent is 10. So 100 plus 10 is going to be 110 multiplied by selling price is how much? Selling price is 30 rupees. If we solve this together, we're going to get our cost price. Okay. So this particular method can be found out to get the mean price. Rather, if we solve this together, how much this comes out to be? This is nothing but 300 by 11. So that is the ultimate cost price at which the mean price should be made of the two types. What are the two types? Rupees 30 per kg is the dearer one and rupees 25 per kg is the cheaper one. In what ratio cheaper one and the dearer one should be mixed up to have the mean price as 300 by 11, because that is the price of cost price of the mixture. Okay, that's what is the situation becomes. Okay, now what else they have given? Must be blended with 30 kg of tea was rupees 30 per kg. Okay, so the quantity of the 30 per kg tea is given. So let us have our method in the scene which says cheaper and dearer and mean. In what ratio the cheaper and the dearer type of quantity to be mixed up so that the ratio becomes D minus M and M minus C and the mean price become M. That is our allegation method which we are following continuously for every question. So in our situation, the cheaper part is 25, dearer part is 30, and the mean price we just calculated as 300 by 11. So let us solve. Cheaper part is going to be 25 for us. Dearer part is going to be 30 for us. The mean price we want to be 300 by 11. In what ratio they should be mixed up to give us that required thing? So we are supposed to do this. We are supposed to subtract and then we can find out the thing. So let us do this. 30 minus 300 by 11. Okay, that is nothing but 330 minus 300 by 11. That is nothing but 30 by 11. Okay, so here it comes out to be 30 by 11. Okay, and the other side m minus c is to be done. 300 by 11 minus 25. Let us do it here. 300 by 11 minus 25 is to be performed, LCM being 11. So it is 300 minus 111. 25 into 11 is nothing but 275, which gives us 25 by 11. So that becomes the part of the dearer type of tea with us. So this is that required ratio in which the tea worth 25 rupees per kg should be mixed up as a 30 by 11 part, and tea worth 30 rupees per kg should be mixed up in the 25 by 11 part. Let us reduce this particular ratio and make it simple more. 11 and 11 get cancelled. So this is 30 is to 25, which is nothing but 6 is to 5. Okay, which is nothing but 6 is to 5. So the ratio of the cheaper type of tea and the dearer part type of tea should be maintained as 6 is to 5 to give away the cost price as 300 by 11. Now they have given one thing. What they have given, the quantity of the dearer type, the quantity of the costlier type of tea is already given to be mixed up with 30 kg of tea worth rupees 30 per kg. So the costlier type of tea is in 30 kg of weight. So where do we have the costlier type of tea? Is the right side. So this 5 part is already given to be 30 kg. So what should be the 6 part? So let us say the 6 part is Z. So whatever is the ratio of Z is to 30, that should be the ratio of 6 is to 5. So we can do it here. Z by 30 has to be 6 is to 5. Here where we can cut the 30 by 5, that is 6. So Z part comes out to be 36 kg. So the cheaper part to be mixed up, the 25 rupees type tea should be mixed up as 36 kg, and 30 rupees type tea should be mixed up as 30 kg to give away the mean price as 300 by 11. And by selling it at now, by gaining 10% profit into it, we can have the selling price which was given to be 30. So we can track our question once again if we can go back. So the tea that of 25 rupees per kg to be mixed up in the quantity of 36 kg, and that should become the right answer, which is available in option number A, and is the right answer.